This is Advanced Math, Unit 8, Lesson 3. Domain and range is what we're working with today. And this is stuff that you've learned. Domain you dealt back with in Math 2. Range and domain you did back last year in Math 3. Okay, so as a quick review, domain is the set of all x values. Set of all x values. Range is the set of all y values. Okay. Find the domain. And for most of the notes today, we are only looking for domain, but know that range is something that you will need to deal with eventually. But most of the notes today are just finding the domain. Okay. Part 1, parabolas. What you should know about parabolas, and it's just the basic U-shape graph. So f of x equals x squared minus 3x plus 2. Now, keep in mind, I'm not going to go through and find the vertex and blah, 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 blah. What do we know about parabolas? We know, for example, this one is opening up. We know it's U-shape. But it doesn't matter if it was opening up, if it was opening down, if the vertex was at the origin or on the x-axis or even on the y-axis. It doesn't matter. For parabolas, the domain will always be all reals because it goes to the right forever, it goes to the left forever. And domain is the set of all x values, and the x-axis runs right and left. Now, you can't see it here, but off to infinity, the graph is getting really, really big. It gets wider and wider and wider and wider forever and ever and ever. It never just stops. So since it goes and gets wider to the right forever and wider to the left forever, the domain is all reals. This is how you wrote it way back in the day, and then last year you learned how to write it like this. And this is the way we're going to be writing it, in interval notation. All reals. All right, that's not true for the range. The range is greater than equal to whatever the y value would be, or less than equal to whatever the y value would be. Okay, so for parabolas, domain is all reals. Now, just know that that is true for regular parabolas, but when there's restrictions, you do have to take that into account. G of x equals x squared plus 5. Such that x is greater than or equal to 0. All right, so you do have to have some general knowledge of what this graph looks like. This graph, you know, shifts up 5, because you learned that last year how to translate parabolas. And you know it's opening up, and even if it was opening down, it would not matter. But the graph is only defined when x is greater than or equal to 0. Here's the x-axis. Values to the right are greater than equal to, values to the left are less than equal to. So this is all I have, is the right side of my parabola. So the domain goes from 0, because it is including 0, bracket on the 0, comma, infinity. It goes from 0 off to infinity. All right, part 2, fractions. Let me box this in really quick. Fractions. Number 1, f of x equals x plus 5 over x plus 3. When you're looking for a domain of a fraction, it does not matter what's in the numerator as long as there's no square root or nothing tricky up there. If it's just a regular polynomial, you just look down here and ask yourself what would make the denominator 0, because remember, denominators cannot equal 0 because then your fraction is undefined. So you would say, all right, x plus 3 cannot equal 0. Therefore, x cannot equal negative 3. X cannot equal 0. Therefore, x cannot equal negative 3. All right, kids often struggle with how to write that in interval notation. What I suggest is just do a quick graph. If x cannot equal negative 3, I'm just going to move that up a smidge. If x cannot equal negative 3, that means it can equal everything else to the left and everything else to the right. X can equal everything except negative 3. Negative 3 is the only number x can never ever equal. It can equal negative 5, it can equal positive 5, it can even equal 0. And the negative 5, it would work because negative 5 plus 5 is 0, but in the numerator that's okay. So you would write that as negative infinity to negative 3, parentheses on the negative 3 because it's not included, union negative 3 to infinity. This is saying everything's going to work except the negative 3. That's why there's no brackets there. Negative 3.5, negative 2.5, all those decimals really close to the negative 3 would not work. Would work, sorry, but the negative 3 would not. Okay, number 2. H of x equals 3x minus 2 over x squared plus 4x okay, x squared plus 4x cannot equal 0. Why? Because that would make my denominator 0. I'm going to factor out a GCF. X, and then x plus 4 cannot equal 0. Solve each one. X cannot equal 0 or negative 4. Zero product property. X cannot equal 0 or negative 4. Again, if you're stuck, go ahead and do a rough sketch. Negative 4, 0 cannot equal those, but it could equal everything to the left of negative 4, everything between negative 4 and 0, and everything to the right of 0. It can equal everything except these two numbers. So you would say negative infinity to negative 4, parentheses because it cannot equal negative 4, and then everything in here, or union, everything in the middle is negative 4 to 0, parentheses on the 0 and the negative 4 again because it cannot equal those two numbers, one more union, and then everything from 0 to infinity. That there is your answer. Okay, kids see this one and they struggle sometimes. X plus 3 over x squared plus 36. Okay, same concept. The denominator cannot equal 0. And then you try to factor, and you cannot factor because that is not a difference of two squares. As much as you try to make it, it's a sum of two squares, not a difference of two squares, which means it's not factorable. So if you try to move over the 36, you get this. And then when you go and square root both sides, you end up with the square root of a negative, which is not possible. So that means there's no solution. That's not your answer. That means there is no number that's ever going to make the denominator 0. And I just put my cannot equal because x squared plus 36 cannot equal 0. I try to solve it. It doesn't happen. What does that mean? No solution is not my answer. That means there is no x value I could ever pick, no real x value, real numbers, that I could ever pick that when I worked this out, it's going to equal 0. It's not going to happen. That means your answer is all reals. So you put negative infinity to infinity. There are no restrictions. Negative infinity to infinity is what your answer is when there's no restrictions. And there's no restrictions, again, because there's no value for x that I could ever square, add it to 36, and have it be 0. Okay, part 3, radicals. Number 1, f of x equals the square root of 7 minus x. Now what you have to remember for square roots is that you cannot take the square root of a negative. You can take the square root of 0, but you cannot take the square root of a negative. So you will always do the inside of your radical is greater than or equal to 0. That is how you do your domain. This is how you would mathematically say you can't take the square root of a negative. The inside must be greater than or equal to 0. So we would say 7 minus x is greater than or equal to 0. Subtract the 7 over. Negative x is greater than or equal to negative 7. Divide by the negative 1. And remembering when you divide by a negative, it does flip the inequality. X is less than or equal to positive 7. How do we write that in interval notation? I'm going to bring the work over here. Again, if you don't know right away how to write it in interval notation, do a quick sketch. It's equal to, so I'm going to shade in the bubble. It's a closed circle. Less than equal to is everything to the left, like that. So that's everything coming from negative infinity up to 7. And because it's closed, or the equal bar, it's bracket on that and always parentheses on the negative or positive infinity. So that means any number to the left of 7, 6, 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, all the way up to negative infinity, all of those are going to work. And any decimal values within that area as well. All right. What if I had g of x equals the cube root of 2x minus 5? That does change things. It's no longer a square root. It's now a cube root. What are the restrictions with the cube root? No restrictions. With a cube root, there are no restrictions. You can take the cube root of a positive, you can take the cube root of a negative, you can take the cube root of 0, of a fraction, of a decimal. There are no restrictions. And remember what I said earlier on this one here, when there are no restrictions for your problem, then your domain is all reals. And since there's no restriction for a cube root, our domain is negative infinity to infinity, which is how we write all reals. So a quick review, or just summing it all up for radicals. What happens? If it is even, that's a square root, a 4th root, 6th root, 12th root. If it's an even index number right there, we know it's a square root. When we don't see it, it's automatically a 2. You learn that in math too. When it's even number, you're always going to set the inside greater or equal to 0. When it is odd, like a 3, a 5, a 7, you're always going to have no restrictions, which means it's always going to be negative infinity to infinity. And that is it for this lesson.